All right, so 5.3, we're going to look at the tan function and graphing the tan function. If you have your unit circles handy, like I have up here in the screen, you can have yours out. That might be good to refer to. We're going to use the unit circle to determine values of tan for a whole bunch of these angles. And then I'm going to show you another way that you don't need the unit circle for. Another way that you can remember these angles without the unit circle. So, all right, so graphing tangent. 5.1 was graphing sine and cos. Now we're graphing tangent. So how many of you have your unit circle assignments back with you? Okay, so if you do, just go ahead and look on there because we also stated the tangent values for these as well. So let's fill in some of these. What's the tangent for 0 degrees? Remembering that tangent of theta is sine theta over cos theta, correct? That's right. So what's the sine of 0? It's 0, and the cos is 1. So we have 0 over 1. Okay? 0 over 1, which is, now is that 0 or is that undefined? Yeah, if 0 is on top, it's 0. If 0 is on the bottom, we got problems. Okay? So this is 0. Tan 0. Everyone see that? Sine over cos. Okay? 0 divided by 1. All right. Okay, so let's move along. 30 degrees. 30 degrees. Pi over 6. You're given sine and cos, so let's calculate tangent. So for 30 degrees, we have 1/2 divided by root 3 over 2. And I won't do this calculation for each one, but this turns into 1/2 times 2 over root 3, which is 1 over root 3. To simplify that, right, and get rid of the radical on the bottom, so multiply top and bottom by root 3, and we're left with root 3 over 3. Is that what you have for pi over 6 tan? Yes? Okay. Everyone understand that? Everyone agree with that? See how we got that? Root 3 over 3. Thank you. Okay? So everyone got that? Okay. Sine, this number, divided by cosine, this number. Okay, this one's easy. A value divided by itself. So tan is 1, right? Notice that everything's positive in this quadrant. Everything is positive. All these values are positive, so tangent as well right here is going to be positive. You can see that. Okay, so what's root 3 over 2 divided by 1 over 2? That's going to be just plain old root 3. Good. And then at 90 degrees, we have 1 divided by 0. What did we say about dividing by 0? Evil, right? Terrible, bad, no good. The answer, your calculator will say error. It'll say, what are you trying to do to me? I can't calculate that. It'll give me a question I can't do. So it's undefined, right? Now we could say that it's infinity is the answer. So I've mentioned before that it's undefined, but we're going to say infinity. We can say infinity here, okay? And that'll be more clear as we start to graph this. Okay, as we go around the circle now, and you've already done this work already, so this becomes pretty easy because all of these values are attached to one another, right? This value and this value. So is this positive or negative over here for tan? Yeah, the cast rule, if you remember, this is the cast rule. Cosine is positive in this quadrant. All are positive in this one. Sine is positive in this one, and this is tan. So sine is the only one that's positive here, so yeah, this is going to be negative root 3 because it's the same values divided as in this quadrant, right? Just with a negative sign. So we've got negative 1, and we've got negative root 3 over 3. Okay, everyone good so far? Yes? Okay, awesome. I won't fill out the rest of these because you do have them kind of on your papers and you can kind of see, hey, these values start to repeat themselves, so I won't fill in these ones or these ones. But I guess it would be good to do this one. So 0 divided by negative 1 is 0, right? Not negative 0, positive 0, doesn't matter, just 0. There is no negative and positive 0. Okay? So if we look over here now and let's draw our coordinate plane. let's go over here, okay, and we're going to do this. Now let's start at 0, so this is 0, okay. What is the value for tan at 0? It is 0, right? So right here, right? Okay. Let's go to pi over 6 now. Okay, so that's pi over 6. So what's happening at pi over 6? We have root 3 over 3. So what is that in decimal? If we're going to place this on our graph, let's figure what that is in decimal form. So the square root of 3 divided by 3 is 0.577. So just over half, let's say 1 is here. So just over halfway up is right about there. Okay, just ballpark. What about 45, which is next? So it's pi over 4, and that's going to be 1. So we go up there and we put 1 in there. The next one on our unit circle is 60 degrees, or pi over 3. And that value, well, the square root of 3, that's the square root of 3. 1.732, okay? So here's 2, so 1.7. Okay, am I going too fast? 732. This is okay? All right. All right, so very much the same that we did for sine and cos, except this is tan. Now when we get to 90 degrees, so here is pi over 2, right? Here's pi over 2. And what do we see at pi over 2? This is where we have our calculator going crazy here when we try to divide by 0. And it's infinity, okay? So dividing by 0 is an undefined answer, okay? If we think about that, this is not part of the domain. That means that pi over 2 doesn't work if you put it into the tangent function. And so how we represent it on the graph is a dotted line for a vertical asymptote. A vertical asymptote. Alright? And that's what we have at pi over 2. That's what that infinity means. Okay? Alright, so we're going to put a few more points on this graph here, including pi over there. And let's quickly write this out, I guess. 2 pi over 3 is right here on your graph. That's the next one. And that's a negative root 3. So we just had a positive root 3. So let's do the negative version, so negative 1.7 or so. Okay. This one is 3 pi over 4. That's this one right here. And that's a negative 1. Negative 1. And 5 pi over 6 is this one right here. And we look at our unit circle, and that's negative root 3 over 3, which is sort of the same value as this, that 5.77, except in the negative. So we put that down here. And then pi, the pi, tan of pi is 0. Okay? Now, interesting enough here that if we kept going past pi, and we won't draw it right now, but if we kept going past pi, we're going to find that these values over here start to repeat themselves. This was a positive root 3 over 3 over here. See that? And if you follow this line all the way along, it's the same values, and they're both negative, so you have positive root 3 over 3 again. And as a matter of fact, because tangent is positive in this quadrant, they're going to be the exact same values as quadrant 1. Okay? So if I write these down just real quick, you'll be able to see. See how this one is related to this one. And that one is the same as this one, and so on. And so we have repeating. And over here, tangent is negative in this quadrant as well. So again, the same numbers, root 3 over 2 and a half, root 3 over 2 and a half, and one of them is negative, so we have the exact same values in this quadrant. Alright, and again, you don't have to write that down, I just want to show you that these values right here are the same as these ones. And these values are the same as these ones. Which means that we have a repeating pattern every halfway around the unit circle. Okay? So we have all positive values, all negative. Then all positive again, then all negative again. So we have actually 2 complete cycles within that 2 pi. So that means that 1 pi, that is 1 time or half a time around the circle, okay, is the period length for tan because it repeats itself again on the second half. It's the exact same as the first half. Okay? So that's one of the things we want to notice. There's a big difference. There's a few big differences, but the period length for tan, okay, period length for tan of theta is 1 pi. Is just pi. It's not 2 pi like sine and cos, it's just 1 pi. Okay? So that's tan theta. That's really important. Okay, I hope you have it all written down because I'm actually going to just kind of get rid of that because I need this space for the graph. So the period length for tan is pi. Now, if I carefully connected these points, now this is going to kind of look maybe just a, this is not graph paper, but if I connect these points, what you find out is they kind of go like this. There's a little bit of a curvature there, and then it races up because all these values in between pi over 3 and pi over 2 are really, really large. Those values are really large. And so it kind of goes up. And as you know about asymptotes, the value doesn't ever equal the asymptote value. It just kind of approaches this asymptote value. So as these values get closer to pi over 2, these values get larger and larger and larger. And so we're actually going to maybe confirm that here, okay? Let's use degrees because it's maybe a little bit easier for us to see. I might have to change my mode. Yes, I will. I'll go over to degrees. You don't have to do this, just watch. Okay? But if I do tan of 60, we know that. That should be that 1.73. See that? Root 3. Now what about tan of 80? Oh, 5.67. Okay? So 80 degrees would be 5, so it's way up here. And what about tan of 89? That's pretty close to 90. And look at, we're jumping way up to 57. So if we did tan of 89.99999, get super duper close, check it out. Okay? That's like 5.7 million. So you see how that graph races up towards infinity, right? Because at 90, technically, the value is infinity, whatever that is, right? So it's super, super large. Okay, is this going over your heads, or am I, yeah, is okay? Do we know what's going on here? I'm seeing some blank stares. I'm not sure if that's like, this is so easy, please go faster, or if this is just generally, math makes me docile, or if this is like, I'm totally with you, teach, keep preaching it. So which one? Option 1, 2, or 3? What are the options again? Okay, so option 4 is you weren't listening. So you want to put up your 4 fingers, okay? That's right, because you weren't listening just now. Anyways, forget it. We're wasting time. Okay, I will just assume you all know what I'm doing right now. Is that safe? Okay. All right. Okay. Okay. Gabe, you creeped out. Okay. All right. So here is the other half, or the other part of this graph right here. Okay. So this one's going to approach negative infinity. As you see here, as we approach 180 degrees, just really quickly, 180 degrees. So tan of 179 is tan of 179 is negative. Oh yeah, because we're approaching 0. Where am I? Right here. See that? That's 179. So it's really close to 0. I meant pi over 2. So let's go tan of 90.9. So that's just beyond pi over 2 over here, right? And that is negative 63. So that's negative, or really, this is 2 right here. So negative 63 is way down there. Okay? Are you getting this? Picking up what I'm putting down here? Okay, a whole bunch of 9s there. Look at that.